video is going to cover section 9.2. We have two main objectives here. One is to understand the intersection of sets and conjunctions of sentences. And the other is to understand the unions of sets and disjunctions of sentences. So, compound inequalities come up when you have two separate inequalities that you join by either the word and or the word or. For example, 3x minus 9 is less than or equal to 0 and x is greater than or equal to negative 5. The and there is saying that both of those conditions need to be met for something to be a solution. Second example is 7x plus 1 is less than or equal to 8, or x is greater than 8. The or tells you that either one of them needs to be met, but not necessarily both, for something to be a solution to that compound inequality. So I want you to add the word compound inequality to your vocabulary list or your group of vocabulary note cards. Those are important. Okay, intersection of sets and conjunction of sentences. Oh, shoot. Let me move this up just a little bit so we can see everything. So the intersection of sets A and B. There's a Venn diagram. This should look familiar to you from some context sometime in your life. But the intersection of those sets A and B is all elements that are common to both. So it is restricted to this part right here. Okay? This funky little shape right here. And the intersection A and B is A and B. I don't know why that symbol didn't come through right in the software. But anyway, it's A and B. Easiest way to remember which symbol to use with which is this is the beginning of the letter A, and then the other one you'll see we'll talk about, but remember that you want to start out in A. A and B. So if we were to find the intersection of these two sets, so this intersection with this, we're just going to write down the set of all things that are in both. A is in both, B is not, C is not, D is not, E is in both, F is not, and G is not. Okay, and the ones that we didn't get here, I, O, and U, those are also not in both. So the solution is this smaller set with only the elements that are common to both sets. With an intersection of sets like this, you'll never get a set that's larger than either of your two beginning sets. Okay? It'll be either the size of the smallest one or smaller than that. Okay, so now let's look at this. When two or more sentences are joined by the word and, the sentence is called a conjunction of the sentences. And when we say sentences, we're talking about equations. Okay, so here is a sentence, here is a sentence, and they're joined by the word and. So that is a conjunction. And a number is a solution only if it's a solution of both. So let's go ahead and solve and graph this problem. And I'm going to move it up just a little bit so I have a little more room to work with. Okay. And for the solution, we're going to solve each inequality separately and graph it. Okay? So and we're going to look for where they intersect. So we're going to have 2x plus 1 is greater than or equal to negative 3. Subtract that 1 from both sides. 2x is greater than or equal to negative 4. So x is greater than or equal to negative 2. And over here, we get 3x is less than 12. X is less than 4. So to graph this, if you look, and I'm going to, on top of the number line, do both graphs so you see how they come together, okay? You wouldn't normally do this, but I just want to show you how they're going to come together. So here we're going to start at negative 2, and it's going to be a filled in dot because it has the equal to. And then we're going to go greater. So that is a graph of the solution for this particular inequality. Over here, we're going to start at 4 with an open circle, and we're going to go less than. So the intersection of the two, I'm going to grab a different color for this, is we're going to have a solid dot at 2, an open dot at 4, and everything in the middle. Because that is what's common to both these graphs. That's where they overlap. Another way you can do this is do square brackets on this end and a round bracket on that end. That's another way to graph it. And both are completely acceptable. Okay. So if there's no way to solve both parts of a conjunction at once, in other words, if their solution sets have no overlap, they're called disjoint. And again, that little symbol's not coming through right, so I have to fix that. Okay? This stands for the null set. So they are disjoint if they have no solutions in common. Now the union of sets, this should be drawn a little bit higher, but you can see that it looks like a U when we're doing a union, so that's easy to remember which symbol we use for that. And the union covers all of it. As long as it is a solution is a solution of one of them, either one of them or both, then it counts. Okay? So to find the union of these two sets, we're going to put in everything that is in the first set and everything that's in the second set that wasn't in the first set. And there is our union of those two sets. Okay, and I'm going to move this up a little bit. So OR is the same as union. So we're going to solve each of them and then graph them. So for the first one, we'll get 2x plus 1 is greater than or equal to 3. 2x is greater than or equal to 2. X is greater than or equal to 1. For the second one, we'll get 3x is less than negative 3. X is less than negative 1. So if we graph the pink one, we'll fill in 1 because it includes 1, and we will go greater. And to do the blue one, we will put an open circle at negative 1 because it's not included, and we'll go less. And that is the graph of the solution set. because even though there is no overlap, there doesn't need to be. Any number that is covered by either the blue or the pink arrow is a solution because it's the word or. It doesn't need to satisfy both, just one of them.